Hello everyone. Welcome to Oemupdate interactive session on CNC machines shaping metal forming technologies. Computer numerical control technology is revolutionizing the manufacturing industry with its ability to cut, shape and form metal parts and components precisely. The demand for CNC metal cutting machines is rising, especially in the automotive, aerospace, defense, medical devices, consumer products and electronic industries. The latest advancements in metal forming technologies have further increased manufacturing efficiency. The growth of automation and Industry 4.0 trends has also fueled the demand of CNC machines, as they offer higher automation and connectivity options that can be integrated into manufacturing process. As a result, emerging economies are adopting CNC metal cutting machines, presenting numerous opportunities for growth in the sector. To discuss the technology, trends, and emerging opportunities, Oemupdate is hosting this discussion on CNC machines shaping metal forming technologies. We have two experts with us today, Mr. Daniel Raravi, Director of Marketing and Strategic Initiatives at Mastercam, and Mr. Pritesh Singh, Specialist Case and Alternative Powertrains at NRI Consulting and Solutions Private Limited.
Welcome, Mr. Puranik. He's asking, any tips to very small scale manufacturers who make small components and supply to tier 2 and 3 industries? Also regarding accidents during manufacturing. Anybody's take?
I think if I understood the question correctly, it was related to a small manufacturing, ensuring that they have a reliable manufacturing process, if I can restate that problem. So manufacturing reliability is of greater interest to people like me because we are in the business of metal cutting. And obviously, one of the major causes of accidents, as he specifically mentioned, and I'm looking at a very narrow view now, very specifically CNC machines that do metal cutting, is typically the setup is not verified, whether it is the setup of the part, the setup of any fixtures, any additional parts, or if there are family of parts kept alongside. These need to be modeled out in a CAM system, and they need to be visually as well as collision verified. The CAM softwares have this functionality. I think in simple terms, it's a training, it's a training question. We need to make sure that there are best practices followed before any output goes to the CNC machines. The other aspect is making sure that the kind of CNC codes that are output, the ISO codes, are verified, and the post processor is created someone with a lot of experience, and it is proven so that these damages or accidents can be curtailed well in advance.
My second question was, how come the companies like Schuler are always a monopoly in the coin manufacturing in all the government mints? Because if you see the tenders of any mint over the period of last 10, 15, 20 years, most of the conditions are exactly matching the Schuler machine. And even if you give a higher technology, it doesn't get accepted by that. So what is so specialty with Schuler, if you have experience with the Schuler? It's a no doubt best machine.
I think, I'm not sure if we should take up this question, and Daniel must be having a much better practical answer of this question, but I have some advice which you can follow to become like the company which you are just quoting. So you mentioned, right, they have been winning all kind of government tenders since last 10-15 years, right? Which indicates that probably they were one of the first companies which was there when these organizations were facing some sort of challenges. And then that point in time, a lot of support was provided in terms of the technology, in terms of finalizing the specifications and other things. So in such manner, sometimes several companies becomes the preferred partner because it is kind of easier for the customer to trust and kind of discuss in detail and kind of take the supports. So if you want to become a preferred partner of, be it a government organization or be it as a private organization, I think you need to be at the right time. After 15 years, it is, I think, not very fair to just say that I have a better technology, but they are not taking. So you cannot actually fill the gap of that 15 years of relationship. A lot of support has been provided by such organizations. So you can also follow the similar approach. It takes a little bit of time, but once clients sees the value in the offering, they definitely try and give the opportunity. That's what I want to say.
Third question is, many customers generally they expect approval for component of production on mechanical press, whereas many manufacturers they use the hydraulic press. Now, what happens in hydraulic press? The speeds are very less, and if the same component is put into mechanical press, either sheet gets torn or distorted. So, what are any tips as far as the die design is concerned in such matters?
I have only brief input on this. Then Daniel, please support me in answering this question. So I think there are people who are actually slowly adopting to servo press, right? I believe mechanical press is a little bit of harder to control, but faster. So somehow I believe that preference is because of the speed. So Daniel, please share if you have any other input.
I think die design is a very complex subject. I think either myself or Pritesh or any die design is extremely complex, and especially the forming side of things. There are numerous other techniques. There's the ballooning way of forming, which is faster in comparison to ballooning, hydraulic, and pneumatic. These are again certain technologies that are alternatives to hydraulic presses. So if the part sustains it, or if the number of shots, as they call it, the number of components that you need to produce also depends. There are different factors. I don't think there's any one right answer to it, but I think yes, these are few of the areas which can be explored in order to have a faster production cycle.
Okay. And the last question is whether 3D printing will replace the metal forming. There's recently L&T has opened some post office in Bangalore by using 3D technology.
I'd like to take this question because this is a topic which is very dear to my heart. So 20 years back, when I used to demonstrate 3-axis CAM software, people used to ask me, "Do you think 5-axis will become mainstream? Do you think 3-axis will go away?" I think the answer is no, not for the foreseeable future, because there are various parameters such as surface finish, which are currently in research stage in additive manufacturing, whether it is metal, whether it is polymers. There are different technologies, whether it is powder bed, whether it is SLS. They are trying to experiment with a number of techniques in order to make sure that eventually a bulk of these parts that make sense to be 3D printed can be 3D printed. So the question is, not all parts need to be 3D printed. I mean, there are certain parts, if you 3D print them, they'll become more expensive than what you're currently paying for it, because they follow a certain set and established processes. So going forward, to the best of my forecast or my knowledge, I feel that it will continue to be a combination of forming. It will be a combination of subtractive machining as well as additive manufacturing.
Yeah, Pradesh, you want to add anything to it?
I completely agree on it, because obviously CNC machining offers greater dimensional accuracy than 3D printing, but many of the times it comes with a higher price tag. So there are situations in which 3D printing can be preferred. For example, I think the most common situation is when we are expecting a very fast turnaround time. The turnaround time is very critical. So 3D printed parts can be delivered, I think, sometimes within 24 hours also. So it's kind of both are going to stay together, and I believe that it will complement, not completely replace, especially in automotive and mass manufacturing, and it will assist reducing lead times, metal forming industries. I also feel like sectors like aerospace and healthcare, which needs and has willingness to implement complex designs, might shift faster to additive manufacturing.
We had very fascinating submissions from our speakers, Mr. Daniel and Mr. Pritesh. So coming to you, Mr. Daniel, you were talking about high-speed machining innovations for quality purposes. So how will artificial intelligence and machine learning impact CNC machines for metal cutting and form?
That is one of the most important questions that is being put across within our circle as well. It is when we discuss strategy in terms of where CAM is headed towards in the future. We often ask these questions to our product team, our development teams. Yeah, one of the major areas in which we have seen benefits of applying AI and ML practices into CAM software is to increase the reliability of knowledge-based machining. Of course, there's a CAD side of things and the CAM side of things. And when it comes to CAD for CAM, which is modeling for manufacturing, there are new age technologies such as incorporating the manufacturing information into the CAD software. Now, typically what happens now is you send a solid model or surface model of any component. The CAM software is unable to understand it intelligently, which means that it does not know if there's a hole. It understands that there's a hole there, but it does not know what tolerancing is applied to such a hole. So let's say, for example, in engineering terms, if we say there's a hole, if it's a 7, or if there's a M12 tapped hole, if there's a countersunk or a counter bore hole, the CAM software currently does not understand these technologies from models that do not have this information. But MBD, model-based definition, is changing that. And in order for the CAM software to look at different sizes of parts incorporated with this MBD information, planning, scheduling, what tools go into it, what material, so what speed and feed parameters I need to use for it, which sequence is best. Should I use the first and last out sequence, or do I have to have a zigzag sequence? Do I start with the smallest to the largest hole sequence? All these are various strategies which are there within the CAM software. Applying AI and ML will help the software assist and present the optimal options to the programmer, so that he or she can then take a look at whether it really is beneficial for my project. Can I use it here? Can I not use it? If I can't use it, what is the next iteration? Whether that iteration is possible. And remember, all this happen at lightning speed, so that there is you're saving on time all the time.
Yeah, thank you, Mr. Daniel. That's quite a deep learning about it. Mr. Pritesh, do you want to add something to it?
No, I think Daniel has covered it all. Generic things I have already talked about, so I have no further input.
Thank you very much, Mr. C.S. Sharma, for joining. Welcome to the forum. We are quite happy to get you. And you were talking about the regulation, quality, as well as sustainability. So what new improvements have taken place in quality parameters by regulatory bodies to improve productivity?
So as I told you that now there is a significant shift in the approach, whether it's a government sector or whether it's a private sector, and it's a paradigm shift. So in not only in the policy formation, but at the ground level, there is a change, and a lot of technological interventions are there. When I say quality 4.0, it means that is an integration of industry 4.0 with quality management system. Quality management system is quite popular since long. Now entire thought process is routing through digitization of the entire process. For example, if a fact its vendors or its aligned services, it means that decision making will be more accurate with respect to top management interventions. So if we can provide real-time data, real-time analysis, risk management, risk assessment, all those tools which are also available nowadays in terms of software applications, entire quality management system nowadays is available in terms of different type of apps. So if we can utilize those services, not only we will reduce the cycle time of maintaining our quality assurance and quality control systems, but definitely the probability of error in those actual physical implementation of quality control and quality assurance system. Quality Council of India, we are also working with respect to chat GPT and AI tools, that how those tools can imbibe our learnings which are being executed in day-to-day practices, and how those chat GPT and AI tools can be utilized for quality improvement. So I suppose the scope is quite open, scope is quite wide. There are a lot of technical interventions and a lot of recent technologies which are giving edge to all those practices, and this will going to lead high quality products, high quality services, and I would say growth in revenue in a sustainable manner.
Yes, definitely. High quality services are required, but for the conforming to the quality standards, upskilling of workforce for CNC machine is also necessary. So what is your say on this?
So when I say quality, it involves 6 factors basically. It is man, machine, material, method, measurement, and other environment. And when I say you talk about skill factor, that is related to first time, which is man or woman, we would say. So I can say that now Quality Council of India was also involved. If we talk about those professional competencies, especially your in terms of competence requirement for CNC machine, now an entire global system is moving from qualification based to competence based system. So whether you are qualified for BTech, whether you are qualified for diploma, whether you are qualified for some degree program, that is not much important. Important is that how you can demonstrate the competence to practice. So in Quality Council of India, we are creating a system, and the same system is being created under Skill Ministry under NSQF framework, where competence of an individual has been endorsed. If a particular worker is fit to work on a CNC machine, despite of the fact that he doesn't have any formal degree or diploma, then he should be qualified for that work. So right now we are working on a system where competence can be endorsed irrespective of degree or diploma. So that is one of the things which we have to endorse, and we have to move further with respect to competence requirements.
Yeah, that's quite nice of you to mention about the competency requirement. Mr. Daniel or Mr. Pritesh, do you have any questions to Mr. C.S. Sharma regarding quality controls for the CNC machine operations?
No, I think this QC did a wonderful job of regulating and setting standards. I think credit is due to them for enabling all the MSMEs to make sure that they have enough learning and the due diligence and capabilities to perform. They are the backbone of our manufacturing. So I think kudos to Mr. Sharma and his team.
Yeah, I mean, kudos to Mr. Sharma and team. I have one. I have one request only. You talked about enabling. When you were talking about the preparing the talent pool for CNC machining and operations, you talked about without any formal degree, there you are putting a structure by which these people can be brought into the system. So, is it possible for you to share more details about it? What it is and how you believe that it can actually attract more number of people and also enhance the quality of the workforce?
Basically, this is related to competence certification. If we look the system for US and Europe, where competence certification is quite visible in terms of practices, whether it's a certification of crane operators, certification of cybersecurity professionals, or cybersecurity individuals. So certification is quite popular. It is different from qualification-based system, because qualification-based system has a certain lifetime endorsement, and certification says that there should be validity of competence, and timely it should need to be upgraded, and it need to be endorsed by a third party. For example, qualification is being checked and assessed by the same party where academics are being performed. At the same time, competence is being judged by a third party independent certification body, which is not part of the training system or knowledge delivery process. So there are 2-3 major differences with respect to qualification based system and competence based system. So this competence-based system is recently adopted by India in terms of various sectors, and wherever in the NSQF quality assurance framework, skill quality assurance framework, it has been graded in terms of 1 to 10, for example, where if a particular person, despite of any formal qualification, he has got RPL, recognition of prior learning, then he can get a certain endorsement formally from the government of India that yes, he is qualified for this particular job, whether he doesn't have any formal degree or diploma. And that is also valid in government jobs also. Earlier that was not possible, but now this competence certification, which is being approved by Government of India, and that is part of new education policy as well, that those type of endorsement are acceptable not only in the private sector but in the government sector. So it will encourage degree or diploma, but if I can get that certification which is based on my competence, not the knowledge only, so that can be utilized by any individual, and that will give credibility to any professional. And one more, last point, that if this competence certification is being done through ISO 17024, which is a global standard for competence certification, then there are more chances that they can get job in the overseas market as well.
Great. I think it's a great initiative because it will not attract more number of people, but also I think for a particular dedicated kind of activity, the competence-based system can work, I think, much better than even the formal education system.
Thank you very much, Mr. Sharma, for your expert views on quality aspects of industrial output and the practice. So moving on, Mr. Pritesh, you were mentioning about the automotive industry. It's surging and giving rise to CNC machining. So what factors drive the growth for CNC market, such as for the laser or plasma cutting machines?
I think in the beginning only I talked about different type of operations, like when I mentioned about the bulk metal operations and then the sheet metal operations. So basically I was trying to point out on two things. One was about the like automotive industry is one of the growth drivers for CNC machines. There are other industries, but I think automotive industry is one of the major industries. And the growth of automotive industry is likely to be much faster than the recent historical past. And that will eventually drive the automotive component industry. And because the components in which these CNC machines are being utilized are going to be very much common in terms of different powertrain technologies. So eventually there will be a much faster growth in terms of these operations. And also this second point I wanted to mention was about this, the introduction of Industry 4.0 will also require, will end into more efficiency. So there again, these operations are going to be utilized more. Last point, which is I think extremely important, is that any industry, when it goes through a massive transformation or massive disruption, sometimes different older technologies are not as much as used. But in this case, this technology has a very positive growth rate, because even if it shifts from one powertrain to other powertrain, from electric, ethanol, methanol, flex fuel, hydrogen, anything, this technology is going to be used. So I think in terms of the growth perspectives, this is fairly well placed.
Yes, definitely. In terms of growth perspective, it is well placed. So, Mr. Daniel, what is your analysis on growth driving factors for CNC machines?
Well, I completely agree with what Mr. said about, that this industry is the mother industry for growth drivers for all machine tools, technologies. I mean, without automotive industries, your just-in-time, your supply chain management practices, your efficiency in terms of OEMs, all of these would not be a topic of discussion here today, because the industry looks at competitiveness at the minutest level. It encourages innovation. Of course, innovation on the aerospace side of things as well. But then when it comes to innovation at versus cost of innovation, which means that how you innovate and how well you are able to do it with thin resources, I think automotive industry has taught us quite about this in the past 140 years. And therefore, it would keep driving. CNC machines, again, are going to be common. Where people had, let's say 10 conventional machines and one CNC or two CNCs, you would see a shift in, that population reducing and the CNC population growing, just because of the fact that, you are able to automate certain parts of it. which you cannot with the traditional conventional systems. So that growth driver is anyways going to come from this shift. But let's not forget the fact that we have to grow in double digits. We are currently around 15.5% manufacturing contribution towards GDP, and it's at 25%. So that number is not small. Trust me, 90 million workforce, and an equal amount of CNC machines, going forward.
Yeah, definitely that has to match somewhere in the future. So, Mr. Daniel, what features do you see in CNC machines that can help improve overall efficiency?
Again, it's the utilization of all of these new age information technology, like smarter controllers, the way in which information is seamlessly passed between CAD to CAM to CNC controls. Right now, although we're doing good, it's not that we're not doing great, but then the information that starts from the designer and ends up in the shop floor at the manufacturing side, there are still a lot of gaps that need to be filled. And information technology, of course, is the answer for that, because slowly we are moving to a paperless communication system on the engineering side to the manufacturing side. The CAD models are going to carry bulk of the information. You will probably start reducing the requirement for printed 2D drawings. You will stop using process sheets which are printed out, because all of this would then start reflecting on your machine tool control screens eventually. Number of innovations that are happening on the machine tool sides, and great to hear it from the machine tool and controllers people. But yeah, our perspective is that there's a hand-in-hand growth between CAD, CAM, and CNC technology, and this is where it's going to probably reach in the next few years.
Yeah, thank you very much, Mr. Daniel. So we are coming close to the session now. I request Mr. Pritesh to give a closing statement, please.
So first of all, I am really thankful for the opportunity to provided by Oemupdate magazine. It's a really great experience and a very good discussion of what we have today. And I think there are several discussions happening around new technologies. Obviously, CNC is also one of the new technologies, but I think this is the mother of all kind of manufacturing. When we talk about the future efficiency, improvements in manufacturing, reaching a very high standards in manufacturing, the CNC machines as well as the workforce which is trained for the CNC to operating those CNC machines is going to play a very significant role. So the efforts which are being done there by the Quality Control of India as part of the government organizations, and also from the actual people who are part of the industry and doing are involved in the manufacturing, like the company which Daniel is running, the Mastercam, and other component manufacturers are going to play a very significant role in the development of this industry. Now, because of the technology, I think there are definitely going to be many positive changes. But I have seen in last 6-7 years, there cannot be a massive change, right? That significant change within very short period of time. But yes, slowly and gradually, I think we are progressing towards more and more advanced manufacturing. So that is all from my side.
Thank you very much. Mr. Daniel, do you want to add something?
No, gratitude to Oemupdate team, Mr. Gopal, Mr. Sudhanshu, Mr. Nair, Ms. Badra. Thank you for having me on the show here. It is such an honor to be here and also to learn from illustrious speakers such as Mr. Pritesh and Mr. Sharma. I think together as a panel, we have probably put forth our views. As long as it benefits the delegates who have attended, of course, the recording also will probably go on to others. But if there are any questions, we are glad to field it here as a panelist or as fellow individual manufacturers, fellow companies involved in taking our manufacturing higher and higher in the country. Please feel free to reach out to us for anything, and we'll be happy to assist you. That's all I have to say. Thank you.
Thank you very much, Mr. Daniel, for your nice comments. Mr. Sharma? we would like to hear from you.
Nothing specific. Thank you very much for inviting me for this session. My apologies once again that I could not join the session on time. But anything related to quality, if you have any query or with respect to accreditation, compliance, certification system, please let me know. I will try to resolve those queries. We have got a dedicated team for that. And if certain other interventions are required in other sectors or other areas, definitely we are going to help in terms of creating frameworks or creating conformity assessment solutions for those sectors as well. So please do write to me, and I suppose Ms. Bhadra can give my email ID to all the participants. And it was a nice interaction. Thank you very much.
Yeah, thank you very much, Mr. Sen, Mr. Sharma, and we will definitely reach you for any of the queries and getting the clarifications. And thank you, all of you, sirs. Now I request Darshana to close the session, please.
Thank you, panelists, for exchanging your valuable thoughts on today's CNC machines shaping metal forming technologies. We hope you enjoyed the session thoroughly. Before wrapping up today's session, we would like to thank our distinguished speakers, Mr. Daniel Raravi, Mr. Pritesh Singh, and Mr. C.S. Sharma. I would also like to thank Mr. Gopal Anand for taking this initiative. We request our delegates and viewers to stay connected with us through our social media platforms. Thermal Control is available on Facebook, Twitter, and Instagram. You can also download our app from Google Play and App Store. With this, we want to announce the closing of today's session. Request you to stay tuned for more